The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to our first virtual edition of the Oregon Data Community. My name is Paul Turley. Joining me today is Arnie Rowland, Vern Rabe, and Michael Wall, part of our leadership committee here. We appreciate all 39 of you so far joining. We have a number of people joining very quickly. We have about 90 people who have registered for this event this evening, and we're obviously working through some changing times, and we're all learning to be very flexible, but we have great technology and great tools, and we have a very strong community, and it's awesome that we can continue to support the community and have so many people involved. Tonight we're going to have two presentations. Vern Rabe is going to be our main presenter. He's going to talk about advanced statistic techniques for advanced query performance. We've had a last-minute change in the short presentation, and I'm going to talk about a COVID-19 report that I've built with the support of a number of my colleagues, both in the MVP community and some of my colleagues at Pragmatic Works. And we'll talk about how you can kind of keep on top of what's going on with all of the data from the CDC and the World Health Organization. So if you have not joined us in the past, we are Oregon Data Community, previously known as Oregon SQL. Let me present my screen, and I'll share, and I'm already going to raise my hand for technical support. I don't see that I can share my screen. Show screen, got my webcam. All right, well, I'm not gonna, oh, there we go. Thank you, Arnie. Which screen am I going to show? I have three of them. Which screen are you seeing? And I will move my browser if it's not the right one.
You see the website. You see the website, yep.
Fantastic. All right, well, that's my laptop screen. So again, we're Oregon Data Community. The URL is oregonsql.org, our previous name. We are a chapter of the Professional Association for SQL Server, or PASS. If you are new to PASS, there's a lot of great resources available at PASS. If you'll just go to pass.org. PASS is probably best known for their global summit, which will be in November of this year. And of course, the big question is it going to be live or is it going to be virtual? Since we still have a few months to prepare. So obviously we want to pay attention to that and see how that develops. And a big event that we also have in connection with PASS is SQL Saturday, which will be in October of this year. And Mr. Wall is going to talk about that. We want to thank our sponsors. Our generous sponsors make these meetings possible. In the past, they've provided funding for food. OHSU have provided a meeting space for us in the past. We have decided that until further notice, our meetings will be virtual. So please watch our website for additional information. We may continue to use this platform, or we may use a different platform going forward as we gain more experience with this. So with that, we're going to have a raffle at the end of our meeting, and the adjustment there is that we're really not going to make this a formal kind of thing. We're just going to randomize all of the attendees. We have a list of everyone who has attended the meeting, so far 56 of you, and we will randomly select someone, and then we'll contact you. The raffle prize, as it has been for the past few months, is a one-year subscription for free training from Pragmatic Works training. And that's a lot of IT training content, very high quality content, all around the Microsoft data platform, business intelligence, data warehousing, etc. All right, well, with that, I'm going to turn the time over to Mike Wall for some announcements.
Actually, Paul, can you scroll your screen up a little bit again before we check it over?
Yes.
Okay.
All the way up to the top.
No problem. I was just going to point out, so one of the things that some people might see this as an opportunity is that if you've been afraid to do presentations before in the past, maybe taking away the being in person fact may make it a little bit easier. So one of the things I was wanting Paul to look at, but if you go to OregonSQL.org or the OregonDataCommunity.org, you can see on the list on the right hand side that we have a list of all the SQL Server user groups in this region. And that would be a great opportunity for you to reach out to them and say, hey, I'd really like to speak about this topic. So that's something I think that you should consider that you could do and be a good way to get your speaker feet wet without having to worry about all that in-person stuff. One thing, but I wanted to talk about options here, about training options. And are we sharing my screen?
Yep,
yes.
I can see it, Mike.
All right, perfect. So there's always been, I've always felt that there was more training than there was time, but now all this training is for free, and it's pretty amazing. So if you look at some of the different options we have, and of course I have to put a cat picture in for Paul Turley because he likes to tease me about it, but everyone be careful. Cloud Skills IO is a site maintained by Mike Pfeiffer, who is a data platform and Azure, or maybe an Azure MVP. And he's very big on infrastructure, Azure architecture, DevOps type of stuff. And so he, on his site, is giving away 16 hours of free Docker training and also 4 hours of free Azure PowerShell training. As you may know in Azure that there's 3 different ways to use PowerShell, and so it's important to learn those different pieces. Also, Pragmatic Works, which is employing both Paul and myself, they are very, they've continued, they've been a sponsor for a long time, giving us a free year's worth of training to the lucky persons into the raffle. But in addition now, they want people who are, really I was told that if you are unemployed, that's fine too, not if you were directly affected by the virus or not. But they want people to have training as an option in order to better themselves. So if you send an email to
we might want to clarify, Mike, that by saying if you've been affected by the virus, we're talking about your employment situation.
Right, not that if you've been infected, but if you've been affected. The point is that I was told that whether you were if you lost your job due to the virus, or in truth, if you were unemployed already, just go ahead and send an email to training@pragmaticworks.com and kindly put Oregon Data Community or ODC in the subject line just so they know where these leads are coming from. Trust me, we're not getting anything other than just knowing. We'd like to know who in our community we've helped. And one point I wanted to say is a success story is that one of the current consultants at Pragmatic Works started off their career by working through the training catalog. They studied and worked through the courses for a couple of years, and they are now currently employed by Pragmatic Works. And I've gone through and I think that their training courses are top notch. And finally, another option from Pragmatic Works is that they have the Power Platform Conference coming up here at the end of the month, April 28th and 29th. From 10 a.m. to 6 p.m. Eastern Standard Time, so a little bit early for us West Coasters, but it's a free option, Power Platform. You know, Paul Turley can certainly talk all about that. Pluralsight, a competitor of Pragmatic Works, also well known for top-notch courses. All of their courses are free for the month of April. Pluralsight has been in the business for a very long time, and they have a very large amount of courses available. Microsoft Learn, one of my favorites. When I recently passed one of the Microsoft certifications, I went through and I used the Learn site, They've really improved it from the old days of the Microsoft Virtual Academy. They've added a lot of new content in. It's interesting. They've gamified it so you get little badges when you complete things. Very relevant. And by using the Microsoft Learn site and buying a practice test, I was able to go through and pass my certification in a fairly short time. And I actually got a decent score too. I think I got like an 85 or an 86%. This one I just thought was kind of fun. If you look here in this website right here, there's just a lot of free things from all sorts of different universities. Also some other sites you may be familiar with, like Udemy and things like that, edX. But anyway, just keep on looking. And then finally, deeply discounted, talking about Microsoft certifications. The DP200 is one of the two parts of the Microsoft Data Engineering role-based certification. Data engineers, it's pretty hot field right now. And it's something that's also, if you look at it, it's just a very good way to learn the Azure Ecoverse. You learn about all the different pieces of it, but he's offering his course normally 1,800 pounds sterling for 300 pounds sterling. If you are unemployed, let him know, and you can pay for it in 50 pounds a month. So email, you got the email address right there and the course address. Yes, we are going to make this slideshow available for everyone here. So anyway, just a good opportunity to learn some new stuff. Better than just watching the news and seeing all the horrible news at all time, even though things look like they're getting a little bit better. Thank you.
Thank you, Mike. I do want to point out that as you have questions or feedback, as a presenter, it's difficult to both present and watch all of the questions.
Oh.
I can't hear you, Paul.
Interesting. I was muted, now I'm not. If you have questions during the presentation, just use your GoToWebinar control panel and go ahead and post your questions. The presenter may not be able to watch questions while they're presenting, but just go ahead and post your questions, and as a group, we'll moderate those. We'll answer the questions for those of you who just need a quick answer. If it's something that should be brought to the presenter, then we'll go ahead and just plan for breaks when we can kind of interrupt and bring those to the group so that everyone can benefit by the presenter answering those questions. So, you know, we certainly want to make this as interactive as possible for a virtual event like this. This is a little bit of an experiment. A lot of us do online events and meetings, and so we have a little bit of experience with that. But as a user group meeting, we'll certainly learn as we go a little bit. So please ask questions and you know, reach out to us as you go. All right, and we will certainly share what we have. So I'm going to go ahead and kick off with a presentation. I'll let me just make sure that my screen is being shared. Mike, can you confirm that you're looking at my blog site in the browser?
Yes, your blog site.
Okay, thank you. So as the COVID outbreak started to become kind of a serious top of mind topic back in late February and the early part of March, a number of people in the community started kind of working together to share data and try to make this pertinent information available in ways that it would both serve the community and also their own organizations. I've been involved working with a large chemical manufacturer in Northeast Tennessee, and what they began to see in their business right away was that a lot of their material suppliers in China and along the Pacific Rim were not able to ship out products. And then a lot of their customers who had placed orders in that region were also having trouble receiving orders. And so they immediately saw this impact and wanted to learn how they could respond to that. So that became a consulting project. And you know, aside from the personal impact that this pandemic has had on our society, you know, business is also obviously being impacted as well. And so this became very top of mind for me, and I started looking for ways that we could curate and obtain reliable data. So with a little bit of research, I found that a lot of the data you're seeing in the news right now is coming from the same source. And there's a group of data scientists within the computer science and engineering group at Johns Hopkins University in Baltimore who have worked very hard to gather data from both the Centers for Disease Control in Atlanta and the World Health Organization, and they've curated that data. So mainly through those two different sources, international data coming from WHO and then US data coming from the CDC, and brought that together. And we found that they're getting these daily data extracts and storing them as text files, CSV files, in a publicly accessible GitHub repository. And so, you know, anybody can go to this GitHub repo and get this data. And so I set out to build a Power BI data set and set of reports on top of this data. And you know, the first effort was fairly simple. Things get more complicated as you start getting into the data, and we started kind of dealing with the same kind of data quality issues that we would typically experience in any client project, especially with data that's being pulled from multiple data sources. So I pulled that into a Power BI data set. I'm just going to show you the reports first, and then I can dig a little deeper and show you how the data is pulled in and how it's cleaned up and how it's being used. But so this is the GitHub repo, which serves as the primary data source. There are a few other data sources as well. If you go to my blog, there are three different ways that you can utilize the Power BI reports that I've created. One is that I've simply published to the web. When you build a report in Power BI and then publish that to your cloud-based tenant, it's possible to publish that to the web so that anybody on the planet can get to it. And that's what I've done here. And this is the resulting Power BI report. Now, if you use Power BI, if you have some experience with that, you know that when you're a subscribed user, when you log into your tenant, that you have access to dashboards, active tiles. There's some navigation options, and a lot of those things aren't available when you publish to the web like this, which is why I've put these bookmark buttons here on this main page. And so, you know, we can just click one of these bookmark buttons, and then you can view on a global level a number of metrics here. Now, the CDC is keeping track of confirmed cases. This is the number that I think most of the news outlets are using to make headlines. You know, 1.5 million confirmed cases worldwide. Well, doing a little more research, I've discovered that the confirmed cases is a number that only goes up. So as the CDC and WHO are gathering these numbers from various countries and other governments, they're just getting the number of cases that have been reported and confirmed. But as people get better, they're not decrementing those numbers. And so this really is the number of people who have been infected by COVID, not necessarily the number of active infections. So I think that's an important thing to know. Yes, it's serious. There are a lot of people who are infected, but we don't necessarily have 1.5 million people in the world who are sick right now. They are tracking active cases. However, that's not a number that's proven to be real reliable, simply because all of these these governments and various entities aren't necessarily reporting that back easily. And then recovered cases, same thing. We're getting those numbers, but I think the people are working harder to report the confirmed cases than they are recovered cases. So essentially what I've done is I've just created a measure that takes confirmed cases, subtracts recovered cases, and that's what I'm calling non-recovered cases. We also have active, recovered, and of course, deaths. So we're seeing that 88,000 people in the world have so far died from COVID. Now, these numbers are going to be about a day late. It takes a day for the folks at Johns Hopkins University to gather and curate the data and run that through their process. They then publish it in their GitHub repo, and then I do a data refresh 3 times a day and try to catch those refreshes, and that's typically a 24-hour turnaround. In this chart down here, you can see by country, the top 10 countries, and the number of non-recovered cases they have. And then this is a calculation of the recovery rate. It's not incredible news, but if you look at some of these charts, you'll actually see that the recovery rate is actually bumping up a little bit in some of the countries. So that's good news. Let me back up a little bit. I wanted to go down the path of sharing with you how you can go get this report and how you can use it. I didn't want this to be something that I create and I just put out there and you have to come to my blog or my published version of the report in order to use it. When I say we, I approached some other folks in the MVP community to help with building this. Honestly, I've done 95% of the work simply because I've spent a lot of evenings and weekends working on this. But you know, for example, we were having some problems getting the data to refresh because we're having to go out to essentially to a website, to GitHub, and to be able to pull back this data and then generate a list of files, and then for each of those files go run a custom function that goes and imports more data. That's not always deemed to be safe when you're going out and scraping websites and using file lists on a website. And so I had to get some help to be able to get that data to refresh. So I reached out to the MVP community, and Reza Rad, who's a very well-known MVP in the Power BI space, came back and he said, yeah, here's a technique you can use. Miguel Escobar came back. Gilbert, whose French last name I can never pronounce, in Australia. Anyway, I got a lot of help from folks out in the community to kind of help build these reports as I went along. So that's one place that you can go. Again, if you go back to my blog, just click on this link to be able to view the report. If you're a BI developer, if you have the chops to actually take this project and either implement it in your own environment, or if you want to contribute to the project, you know, I've had some people with an AI background, a machine learning background say, hey, you know, I know Python and I know R, and I've got some ideas for how we could do some predictions and correlations and things, and you know, I'd like to contribute and use my skills to do that. Knock yourself out, please. Here you'll see a link to the GitHub repo where I've actually shared out the latest copy of this PBIX file. I've also invited others to do the same thing. I've had a couple of takers. You'll see that in the archive report files that Jamie Johnston, a data platform MVP in Houston, has created his own version of the report that he's posted here. So I would encourage you to download it and play with it if you have an appetite to do that. The third way that you can use this report is after I had published this to GitHub, was actually approached by a program manager at Microsoft who came to us and said, hey, could you build a Power BI template app that people could install into their tenant? Now, template apps can only be published by Microsoft partners, and so I went back to Pragmatic Works and essentially said, hey, let's work together to build this template app. We can publish that through our partner association or relationship with Microsoft. And let me show you how that's done. So if you go to your Power BI tenant and go up here to apps, you can see that I currently do have the app installed. And you know what? I'm actually going to remove the app so that you can see this. Well, I mean, I'm not going to take the time to do that. I'm going to change my mind. All right, so you just go up to Get Apps. And you want to install this from App Source. So don't click that link. That actually just takes you to a web page. But if you go to Apps and search for COVID, you'll see that there's our app. So this is the one that I've created and published in the last few days. A couple of other organizations have also contributed their own offerings here. Say Get It Now. And that's going to install this app. So when you create a data set, reports, a dashboard, all of those things can be packaged up as an app in Power BI. And because I already have a version installed, I can say, do I want to overwrite the one that I've already got installed? Let's go ahead and do that. And I'm not doing a version update, so we're just overwriting this with the same version. But once that's installed, you'll be prompted to connect to your own data. And the concept behind a template app is that in another scenario, you might want to connect to data in a gateway, through a gateway that's on-prem or your own set of data. There's only one source of data here, so it's all the same thing. But you still have to connect this. And I guess it was smart enough to know that I didn't upgrade, so it didn't prompt me to connect. Let me just show you where you do that. So I'm just going to go to the actual app workspace. Here we go. Yes, connect data. So you click on connect your data, and you'll be prompted to provide connectivity information for two different data sources. They both happen to be in the same GitHub repo, but they point to a different set of files. And all we need to say is we're going to connect as anonymous, so you don't actually have to authenticate, but you do have to say that that's a public data source. In other words, I'm saying that it's okay to connect to this data. So I choose public, click sign in, being prompted for the second data source now, click public and sign in. And now I'm connected. So now I have this app in my own Power BI tenant. If you go to datasets, now I could go schedule refresh. Let's wait for that to update. So this is actually doing a refresh right now. It's actually going out to that GitHub repo and refreshing the data. If there were new data files, then we would see that. Then I can go to settings and say, I want to schedule a refresh, keep my data up to date. And in the app, I had already designated that there were 3 different times during the day that I'll go out and look for new data. I'll hit apply, and there you go. So we're done. So let me just jump back and show you some of the other features that I built into this report. Again, I'm using the publicly accessible, the published to web version, which is most accessible to everyone. We go to global case locations. You'll see a pair of maps. Let's try that again. Ooh, it's alarming that that's not working. Okay, rather than wait for that, I'm gonna, oops, jump, oh, shoot. There we go. All right, anywhere you see a country, a state, or a date, you can get to more details behind those items. So for example, if I want to see more details for the United States, if I hover over the United States in this map, then you're seeing several different measures here related to the United States. If I click on the United States, and that's going to cross-filter the rest of this report, and we'll just wait for that to update here real quick.
Hey, Paul?
Yes.
So we have a question from Jenna, and she asked, when you go to get new data and you already have the data set, will it be smart enough to just pull deltas, or will it clear what you have and re-pull all?
Because this is a web data source, Power BI does not have the capability of doing an incremental refresh. If my data source were a relational database like SQL Server, then I would be able to do that. But in the case of a web data source like this, it's a full reload of that data. Fortunately, this is a fairly small set of data, so it doesn't take very long to reload.
Cool, thank you.
You bet. All right, I'm going to right click on the United States and just show the drill through options. Let's say that I want to compare these metrics now by state. So if we choose drill through and go to country state profile, then that's just going to show us the United States in this page. And then we're seeing the top 10 countries by non-recovered cases. Obviously New York up on top. And an easier way to see this is in these tables over here. So you can see that New York is at the top of the list with 151 non-recovered cases, followed by New Jersey, et cetera. I'm not pleased to see high numbers here at all, but I am pleased to see that my home state is not in the top 10 anymore. But if I did want to look at numbers by county for a state, let's go down to Washington. So you can see that there are currently 9,200 non-recovered cases in the state of Washington. I'm going to right-click on Washington, and again I have another drill through option, so I can go down to that state profile, and that's going to show these numbers to me now by county. Now, as we're running out of time here, there are a couple of other pages that are very notable as we're watching how the outbreak progresses. A lot of you are probably watching, the TED Talks and the interviews with Bill Gates and with, forgetting the gentleman who was the CEO of the vaccine consortium. Sorry, that's not coming top of mind right now, but they're talking about this peak. We're all looking for this peak, the point where the recovery rate starts to get higher than new cases, and we're seeing that in just a few different regions so far. If we look at trends by country, for example. We can see our top 10 confirmed cases right here, and you can see that the United States is still climbing very sharply. According to China's numbers, they're starting to drop off, and we're starting to see that in other countries as well. I wanted to show you some forecasts that I've done. The forecasting algorithms that I'm using are very, very simple. This is based on available data, and so don't invest too much into any kind of a prediction. So because we're not seeing this peak yet, we're not seeing it drop off as they're predicting, we don't have data to suggest that there is a peak yet, and that there's been a decline in cases. Therefore, if we look at the 30-day forecast, this is simply based on what's called an exponential smoothing algorithm. It's a well-known algorithm. It's built into Power BI, so I'm not running any kind of a cognitive service or a machine learning experiment or anything like that. But we're simply going to extend this slope out 30 days, which would take us out to May 8th with a median forecast of 2.8 million infected persons. If that were taken out 120 days, and a statistician would tell you that we don't have a basis for that, but we can, perform the algorithm, and that would take us out to a much higher number. So again, we're really looking for that peak, where we're looking for that decline as they're telling us that we should expect in the next few weeks, and you're going to see some drastic changes in these forecasts, and hopefully some much better news. And then finally, I I did bring in world population numbers and looking for you know, some indication of you know, the correlation with population densities and things like that. And what's interesting is that there really doesn't seem to be a correlation. There certainly is some suggestion of smaller countries, you know, having a higher number of cases. So, for example, if we look at cases per million, so this is the per capita numbers were so small that it was just a very, very small percentage. But so if we look at cases per million, you can see that Holy See, which I believe means the Vatican City, very high number of cases per million, but they also have an extremely low population. San Marino, which is a state in Italy, for some reason the WHO has that listed as a country with only a population of 34,000 people. Cases per million, still very, very high. Liechtenstein, Monaco, you know, Luxembourg also have pretty high cases per million and cases per capita. So I think I'll leave it there. Most of these pages are pretty easy to read and figure out if you've had a little bit of experience with Power BI. But if you do have questions, please reach out to me. The easiest way to do that is through my blog. And I am encouraging people to post comments on my blog. Let me just come back here, and you'll see that in this recent page, I've got 3 comments here. And if you go back to an earlier page, let me go. Sorry, let's go back to my main blog. This is the 3rd most recent post. So sorry, I'm having problems navigating my own blog. Let's go back to March. And here you see that I've had 65 people who have posted comments to the original post. So anyway, if you have questions about using the report, or if you have additional ideas, please post to my blog. I'm you know, pretty busy with my day job, but I try to check this at night. So I go ahead and just cap that off right there, and turn the time back over to Mike to let me know, Mike, if there are more questions. I'm only seeing the one right now, but I'm also not able to expand this window in.
You need to click on the little arrow. No more questions I see, but everyone, this would be a great time if you had any questions for Paul. Not that we can't answer the questions at the end of the sessions too.
Yep. All right, well, thank you.
Well, at this point, I think that we're going to go ahead and, just like we do normally, we're going to take just a few minute break. I understand we're in a virtual world, so people can easily sneak off, but just the same, I'm still going to count down 3 minutes so people can go get a fresh drink or something like that. No break. Okay, no, I guess we're not going to do a break.
Well, and Mike, I just wanted to mention that I actually planned to do a very short presentation, so I didn't really have anything formal prepared, but I will be presenting this solution in a much more structured format in 2 weeks at the Portland Power BI user group. And that's easy to find at community.powerbi.com. But if you are interested in seeing how this is kind of teased apart and how I built the queries and how I structured the data model in Power BI, then that would be a good time to join the presentation.
All right, sounds good. Well, we do have one question from Mark. He's asking, do you have to create the relationships in the data model?
Well, Mark, since you, let me answer that. So the data model is relatively simple. The imported data from that set of CSV files that you saw is in this main table. We'll call this a fact table, case details. The geographic information that the CDC and the WHO provides is really, really dirty. We've got countries that show up in 7 different ways, and so it took a lot of brute force methods to kind of tease that apart. But I created 2 separate bridging tables to get there, and then I imported this population by country information from. It's actually coming from a Wikipedia page, so that's a separate import. And the rest of these tables are really just used for utility purposes. So hopefully that answers your question, Mark.
Okay. Thank you for that, Paul.
You bet.
The one thing I wanted to show was what I was alluding to. And, just show my screen here really quick, and I just wanted to point this out again. Is it down here, like I was talking about, the regional user groups. But if you click on any one of them, you're going to be able to find the contact information on how to each one of these. And so I know that I have spent a lot of quality time working with our friends in Eugene and Olympia. And then, of course, we have our friends down in Tigard in the Portland SQL Server group, and then, of course, the Salem SQL Server group. So there's 4 groups that are all very close by that would love to hear from you. So I think that's just a great opportunity. But next, let's, everyone knows how good Vern is. So Vern Rabe is going to be doing our next presentation on advanced statistic techniques for advanced query performance. So this is a great presentation, and I hope everyone enjoys it. So Vern, take it away.
Thank you, Michael. Let me see if I can take the screen. Let me know if you can see my screen. I can't see it.
Yeah, it looks good from here, Vern.
You can see it okay? Okay.
Yep.
And
Yep.
so now you see the slide. And just to test, you can now see the management studio.
Yes.
All right, I'm a go. So as Michael said, we're going to talk about advanced statistic techniques for advanced query performance. And if you don't know me, here's my slide. And I really like to point out 2 things on here. Number 1, how old I am, because I've been working with SQL Server since version 4.21a. And my first PC had a 10 megabyte hard drive. So as I said, that points out how old I am. But there is one more thing not on here. I apparently am quite an optimist because with all the difficulties with the coronavirus and having to telecommute and social distancing, there is one aspect that I can take advantage of, because now, if you can see my screen, I can enjoy some of my Pinot while I'm giving a presentation. So that's usually not possible. So what we're going to cover today, first of all, we'll have an overview of the optimizer, because after all, the optimizer is key to anything having to do with performance in SQL Server. A review of statistics. We're not going to go into it in detail, but we will have a review. Some things about reading statistics, and I'll point out a bug that exists when reading statistics. And then we have some specific statistic solutions, some things that you can do creating different types of statistics to solve specific issues. So the optimizer. The optimizer is an amazing piece of software within SQL Server, and its role is to accept the query that someone submits and determine how to execute it, step-by-step process, the plan. And that's not a simple task. And to give you an idea of just a little bit of the complexity, let's say that you submit a query that's joining 2 tables. Well, there's 3 different types, not counting the hybrid version in 2019. There's 3 different types of join operators. There's a nested loop, a hash maps, and a merge join. So each of those has to be evaluated. And then within each of those, are we going to join table A to table B or table B to table A? So right there, there's 6 possibilities. If each of those tables has 2 or 3 indexes, the optimizer needs to look to see if those indexes are appropriate to use. If there's a filter, a predicate, does the predicate happen at the index level? Does it retrieve the rows and then throw out the ones that don't satisfy it? Or does it return all of the rows to the next operator and let some sort of filter later throw out the rows that don't apply? Many, many choices. If you have a query with 5 or 6 joins in it, it's not unreasonable to have literally millions of different plans that could be executed to come up with the accurate results, and the optimizer has to figure out which one to use. Generally, what happens is at first, a threshold is determined per query. You submit a query, and the SQL Server looks at the query and says, you know, we should be able to execute this query with no more than X amount of work. And that X is the threshold. And then the optimizer starts going through the various choices. Let's try this plan. Let's try this plan. With each plan that it tries, it comes up with an estimate of how much work it would be to execute that plan and compares that estimate to the threshold. If it is greater than the threshold, it keeps going. If it's less than the threshold, it stops right there and says, that's the plan. That plan is not necessarily the best plan. If it kept looking, it may find a better one. But that plan is good enough, and therefore it's used, because it's a toss-up between how much time do I spend trying to find the best plan versus having the best plan. So the good enough plan is what the optimizer comes up with. When it looks at a table or index and says, okay, how many rows do I expect out of this? It uses a cardinality to come up with that. Cardinality is an estimated number of rows out of an index or a table. If it's got a very low cardinality out of one table and an appropriate index exists on the other one, then it's likely it's going to pick a nested loop. If the 2 tables being joined both have a very large number of estimated rows coming out of them, then it's possible that it's going to do a hash match, or maybe if they're sorted correctly, a merge join. The point is that the number of rows it expects to get out of a table or index is a major, major factor in what the work that the optimizer thinks that this plan is going to take. And that cardinality is determined from statistics. So there we get back to the core of this conversation, is that statistics come up with estimated number of rows. Those estimated number of rows are used by the optimizer to come up with the amount of work that it thinks a given plan will require. And then it compares that to the threshold, and whether or not it's good enough, uses that plan. The cardinality estimator was rewritten in 2014, and I'll cover a few of those things during my demo, but one of the things to think about is that if you're doing an upgrade from before 2014 to 2014 or newer, there are very specific steps that you should follow during that upgrade, because the cardinality estimator, although it was an improvement in most of the areas that it was done, well, I'll say all of the areas that was an improvement, it is not perfect. And if you're upgrading to 2014, likely you will see the vast majority of queries, well, most of the queries won't improve. Many queries will get much better simply by upgrading, but then you'll have a few outliers that, even though it's a better estimator in most cases, every once in a while you'll have a case where a query gets worse. So if you're going to upgrade to 2014, make sure to look up the right way to go through that process. So now we're going to have an overview of statistics, and I usually don't like to read off of a slide, but this one just fits so well. It's an estimated summary information of distribution of values in one or more columns. There's a couple of key words there, estimated. That is absolutely key to remember anytime you're dealing with statistics. They are rarely ever precise numbers. They're estimated. Summary, if you have a large table, you're not going to have all the details of all of the values in a given column. You're just going to have summary information. And the main thing and I'll get to it in a little bit, the histogram, is that it's a distribution of values. So it's a summary of that distribution of values. So what are statistics? What creates them? Any index that you create will have a statistic on it. And that includes primary key and alternate key constraints, which of course have underlying indexes. You cannot drop that statistic that's associated with an index. The statistic has the same name as the index. It's locked to that index. You can't break it apart. You want to get rid of the statistic, you have to drop the index. By default, if you reference a column in a predicate, where clause or a join on clause, by default, if a statistic does not exist on that column, one will get created. That's a good default. Typically, you want to leave it on. Lastly, you can define your own statistics, and we'll get into a few of those at the second half of this. The statistic consists of three parts: header, density vector, and histogram. And for this presentation, I'm not even touching the header and density vector, only the histogram. The histogram has up to 200 steps. Each step contains a sample value from that column, from the column, or if there's multiple columns in that statistic, it's the first column. And it gives you an estimate of the number of rows in the table that are equal to each of those values. And it gives you an estimated number of rows in the table that are less than that value and greater than the previous value. All of those numbers are used by the optimizer to come up with the estimate, the cardinality out of an index or a table. Michael, what I'm going to do, I've got 3 main slides with several things to cover on each slide, but at the end of each slide might be an appropriate place for questions. So are there any questions so far?
Nothing yet.
Okay. I will continue on with reading statistics.
Oh, wait, we have someone raise their hand. Let's see what that was about.
Okay.
I guess I'm not sure. I think someone wanted to. So everyone, if you want to ask a question, just go ahead and just type in a question. You have the little questions tab over there on the right hand on the go to webinar panel. So just type in a question and everyone will see it. And then we'll make sure it gets to Vern or answer it online.
Okay, on to reading statistics. One method that's been around, I believe, from the beginning is DBCC show statistics. And when you execute that statement, you include as parameters the fully qualified table name and the statistics name. That will return by default, return 3 result sets, the 3 parts of the statistics, the header, density vector, and histogram. But usually I'm only interested in the histogram. So you have the option of adding with histogram, and doing that returns only the histogram. The next method to read statistics is one of the dynamic management views, DMDB statistics, either properties or histogram. And again, I will almost always use the histogram. And the 2 parameters for that are, instead of the table name, you pass in the table object ID, and instead of the statistics name, you pass in the stats ID. This dynamic management view is available as of SQL Server 2016. There is the Service Pack cumulative update. And my little red dot means that I have a demo. I'm going to show you these. So the first thing I'm going to show you is this query. is a convenient query because remember those two methods require either the table name and or the table ID and the statistics name or the statistics ID. So this query will return every statistic object for the specified table and where the first column in that statistic object is the specified column. So I use this a few times in my demo. And by the way, these slides, the slide deck in these demos will be available on our website. So when I execute this, oops, don't want to see that. I want to execute it. And as you can see, it's ID 7, and there's our name. And Paul is proud that it starts out with his home state of Washington. So now that we know what parameters these two methods require, I'm going to execute both of them where I pass in the table name and the statistics name, or the object ID of the table and the statistics ID. And in the case of dynamic management view, I've just limited the column so it'll match exactly what the DBCC returns. And let's take a look at and just review these columns. So we'll look at the dynamic management view output. This is the column that holds the actual values, or this in the column that we're referencing. So we looked at carrier ID or something like that. So these are all the values in that column. The third column over is the equal rows. That's the estimated number of rows that should exist for that given value. So this row, for instance, says that there should be 47 rows with this value in the table. The range rows, let's take a look at two columns. The range rows, that's this guy here, says that this number says that I expect to have approximately 342 rows in the table with values greater than that and less than that. So that's a range rows in between those two, non-inclusive of the endpoints. And this column is the number of rows it expects to exist with the number of different values that exist in between those two. So let me get back to this. This 18 says that I expect there to be 18 distinct values between these two. So with all that information, the optimizer can come up with its estimate of the cardinality, the number of rows based on the predicates, the index used, everything else. I want to point out one thing on this. Up here is DBCC output. Down here is the dynamic management view output. They are sorted in the same order, but notice the null, and there is no null. This is a bug in SQL Server. And in fact, if you want to vote on it, go to feedback@azure.com and say, hey, that's a bug that you really should fix. And all you have to do is search for statistics, search for DMDB statistics histogram nulls, and it should come right out with this bug. Okay, pausing on that one. Any questions come up, Michael?
We had one question, which I'd like to think that I answered, but obviously get it from the expert here about how often should stats be reset and cleared. And I said that, the good practice is you should reload your stats nightly in busy tables, and re-indexing will cover the stats in the indexes. And you only want to reset if you had to for some dire reason. But would you like to add to that?
So I'm not quite sure what you mean by reset, drop and recreate. I don't know, but there's a lot of discussion of that. Number one, by default, automatically, well, any statistic, unless you change that default, will be updated automatically when a certain amount of rows get changed in the table. Often that is sufficient. Sometimes it is not. And that's why people get in the habit of updating the statistics nightly. One of the downsides of doing it nightly is if you have a whole bunch of query plans in your cache, one of the advantages of having them there is that the next time someone executes that query, the optimizer doesn't have to go through that process of determining how to execute it. It's already been determined, and it just reads the plan out of the cache. When you update statistics, that inactivates those caches. So effectively, the first thing the next morning after you update all of your statistics, all of those queries that come in are going to have to optimize for the first time. Sometimes that's hardly noticeable. Sometimes it's quite noticeable. It definitely is a case by case. So
and that makes perfect sense. Now, yeah, no, I can see that. You want to save the time. Yeah, and I think you answered the person's question. She said that's what she meant by reset and clear stats. So apparently there was some heated debate at her work, and so she wanted to be able to win the cage match. So
yeah,
anyway.
you ask 100 people, you get 99 different answers on that one. It really depends. And again, what I'll say is that in my experience, the majority of statistics, the automatic updating suffices, but there are those cases where you need to manage them separately.
Makes perfect sense.
Okay, anything else?
That's it for now.
Okay.
There's another question coming, but I'm just going to respond to him on the chat. So go ahead.
Okay. Now we're going to have some specific solutions that statistics can help you with. So the first has to do with correlated columns or correlated predicates. What does that mean? So let's say that you had a query and you had two predicates. You said, select from these tables where the date is greater than the first of this year and the sales quantity is greater than 5. So knowing that you're only looking at sales this year, are you more or less likely to get volume greater than 5 than you would have last year? If you are, then they're correlated. One depends to some degree on the other. If they're totally independent, they're unrelated, they're not correlated. But let's take a different example. Let's take city and state. If I selected from a table and said where the city is equal to Seattle and the state is equal to Washington, those are closely correlated. So when I say filter by Seattle, and adding the filter of Washington isn't going to filter out very many, if any, additional rows. The end result is that, well, the optimizer, when you have two predicates like that, doesn't know if they're correlated or not. It has no idea which columns in which tables are related to one another. Prior to 2014, the assumption by the optimizer was they were not correlated at all. Starting in 2014, the optimizer assumes a certain degree of correlation, but this degree or the lack of any correlation applies to every query. There's no exception to it. And so when you get things that are closely correlated or not correlated at all, the estimate that comes from the optimizer may not be accurate enough. So one solution sometimes, and by the way, point out that many of these solutions are not, wow, I'm going to go home and do this right now. It's going to fix a whole bunch of things. These solutions every once in a while solve a problem. Most of the time they don't help. And that's why whenever you want to consider one of these, you literally have to experiment to see if it works in that particular situation. So when you have correlated columns or predicates, sometimes you can use a filtered statistic to help that. So we were just looking at, let me conditionally drop. By the way, I want to point out again, this is for Paul's benefit. You know, the automatically created statistics start with _WA because Microsoft is proud of Washington. Well, I'm awful proud of Oregon, so I underscore OR with the beginning of my predicate or my statistics.
Well,
So,
if you can get Microsoft to move to Oregon, Vern, then you can do that.
so conditionally drop it just in case I already ran it. So the first thing we're going to do is we're going to take a look at a query. And this query has two predicates, a product ID and a carrier tracking number. So the question is, are those two correlated? Well, depending on which version of SQL Server I'm running under, it's going to assume 0 or some small degree of correlation. But I happen to know that these are very closely correlated, but I'm going to execute this and see, oh, I've got to turn on actual execution plan. By the way, if you're not familiar with it, actual execution plan, I use it all the time. And that's a toggle button to turn it on and off. And I now have it turned on. I will now execute it. And when it is done, look at the actual execution plan. And what I'm going to focus on is any difference between the estimated number of rows and the actual number of rows. And going back to the terminology here, I called that the actual execution plan. You'll see a lot of people say that that's really not the actual execution plan. It's the estimated execution plan with some actual statistics. Well, okay, I'll call it the actual execution plan. If you have a relatively new version of Microsoft SQL Server Management Studio, and I highly recommend that you get one because they're backward compatible, right here on the screen, you can see the difference between the estimated and the actual row count. And that's what you're looking for. Whoops, wrong button. And I'm doing it again. So this says that it estimated 1,430, but got an actual of 0. That's quite a ways off. If I'm troubleshooting a slow performing query and I see, one of the first things I always look for is a significant difference between the actual and the estimated, then I'm going to hone in on that. Because this is right out of a clustered index. That didn't do well, did it? Since this is coming right out of a clustered index, it is likely that it is an issue with statistics, maybe not enough granularity, maybe statistics are bad, I don't know. But in this case, I'm going to focus in on statistics. If, by the way, you do not have a most recent version of Microsoft Management Studio, instead of seeing the differences there, you have to hover over this line and you'll get a little context menu that comes up, and there you'll see the same things. Actual number of rows and estimated number of rows. So now I'm going to look into the statistics. And when I look at the data, and I'm not going to do that here because it takes a bit to analyze, I come to the conclusion that these two are closely related. And notice that we got 0 rows. So because we have 0 rows, I'm going to create statistics where the carrier tracking number is null. And I looked at the table, and there's a good percentage of rows in the table that are null. And since I might filter a fair amount with null in my predicate, then this will narrow my search down. And in this case, it will take care of the correlated predicate issue. So I'm going to create this filtered statistic. And then I'm going to execute the exact same query again. And again, look at the execution plan. And now instead of a merge join, I have a nested loop. Why? Because it said, wait a second, I'm not going to get 12 or 13 or 1,400 rows, whatever it was. I expect 1 row because it can never estimate 0. It has to estimate a minimum of 1. And 1 row and a decent index will give you a nested loop. Another thing I want to make a note of, reading blog posts, you will occasionally see someone say, how do I get rid of these nested loops? Implying that nested loops are bad. Of the 3 types, all 3 have the right place. They have their place. This is the right place for a nested loop. A hash match or merge join would be slower than a nested loop here. So it's just that it has to be used where it's appropriate and not appropriate. So don't get in the don't get the opinion that nested loops are categorically bad. Another way of sometimes handling the issues caused by correlated columns or predicates is a multi-column statistics, one that covers the columns involved with the correlated columns. So I have a different example here, and again, I'll conditionally drop it in case it exists. I had mentioned before, like Seattle and Washington being correlated. Well, my example here is London and England. And I'm going to show you, first of all, the first two queries. I'm just going to query from the address table where the city is London, and then a second query just to show you how many rows there are in England. Now, obviously, if you're going to select London, I don't know if there's any other place that has a London other than in England. So these two are very correlated. So when I execute this and look at the actual execution plan, notice that 434 rows are in London and 1,954 are in England. And I will bet you that every one of those 434 is in England. But if I combine those two predicates into the same query with this guy right here, the optimizer doesn't know that they're tightly correlated, doesn't know that once it has London, adding another filter of the England being the state or province ID, country, is going to reduce the rows at all, but it doesn't know that. It assumes, depending on the version, some degree or 0 degree of correlation, comes up with a different estimate. So in this case, we are getting an estimate of 43, and again, the actual of 434. So every London is in England, but that's far enough off. Now this query right here is really straightforward. It's not a performance problem, but this table, the output from this may be joining with something else, and that estimate's going to be off, and you might end up with a slow query. So even though this isn't slow, we still want to get these numbers, want to look at how to make these numbers somewhat close. So what I'm going to do is I'm going to create a composite statistic, one that covers two columns. And I have yet to determine how to determine this, but sometimes you want the city first and sometimes the state first. I think that you want the determining one before the determined one, I think, but I haven't done enough testing to confirm. But the point is now we're going to create a statistic on these two columns, and then when we submit that same query, the optimizer can use that information, same query, and when I execute it and look at the execution plan, and now I estimated 407. That's pretty darn close. That's close enough for me. Again, this query is not slow, but it may be part of a larger query that could be slow, in which case these two predicates being tightly correlated could be an indication that a statistic covering them both might help. Another thing that this kind of points out is that it seems counterintuitive. You would think that adding more and more predicates would help the optimizer come up with a good plan. But because of correlation, the more predicates you add, the more likely you're going to have some correlations that's misestimated. So be cautious of adding additional predicates when they really aren't needed. Insufficient granularity in huge tables. This is one that I have been working on to get a demo, but I haven't gotten one to work, so I get to describe it. So you have a huge table. Let's say we have a table with 1 billion rows. Think about what the histogram has. The histogram has up to 200 values out of that table, out of a given column in that table. 200 out of 1 billion is a pretty small percentage. If the data in that column is skewed. In other words, at some point in values, there's a whole bunch. At another point in value, there's hardly any. Then that granularity is going to cause some inaccuracies in those 200 steps of the histogram. This is very much dependent upon the skewed data. If the data is very regular, very consistent, then you typically won't have issues of performance because of it. When that happens, what you can do is you can create filtered statistics. So let's say that you had a table of sales, and of course in that table you're going to have the date of the sale. And you have millions and millions or hundreds of millions of rows in that table. You might say, look at, I usually query this for a given month. So why don't I create a statistic for every single month and then filter it so that it only sales within that month will be included in the statistic, in the histogram, the 200 steps. Much better granularity. And then when you query it, the optimizer has a better chance of getting good information from that more finely tuned statistic. Another thing with statistics is that because in many cases, when the statistics are created or updated, the entire table is not scanned. There's an algorithm to pick out samples, and from those samples come up with the histogram. And that algorithm is not perfect. It doesn't know what data is in the table. It's trying to determine what data is in the table. And if there's skewed data, or even if there isn't skewed data, sometimes the statistic can simply be bad. And here is an example from the sales order detail, sales order header. I don't know if I mentioned, but everything I'm doing is in AdventureWorks 2016 or AdventureWorks DW 2016. A lot from the sales order header and sales order detail table. I have a single predicate. I want to look at the rows where the order quantity is equal to 15. Pretty simple query. So when I execute that, and I look at the execution plan, again, I am looking for discrepancies between estimated and actual, and that's a pretty big discrepancy. Estimated of a little over 11,000 rows and an actual of 119. This is the sales order detail. And again, since this is coming right out of a clustered index, I'm thinking, well, maybe I have an issue with the statistics. Let's take a look at the statistics. And since I was filtering on the order quantity, let's take a look at the statistics on the order quantity column. Going back to my query to identify the statistic or statistics on that column, I execute that, and it tells me that it's stats ID of 6, and there is that name of the statistic. So let's take a look at the histogram. So remember what these columns mean, and let's take a look at this right here. So this row says that there are 230 estimated, 234 rows equal to 14. This one says there's 111 equal to 16. And this says that there's 11,000 rows in between these two, in between 14 and 16. And number one, we know it's an integer, so there's only one value. And secondly, right here says that there's only one distinct row in between. So this is telling the optimizer that there's 11,000 rows with a value of 15. That's exactly what we saw in the estimated row count. I mean, that looks awful suspicious. And so let's take a look at the data in the table and see how many rows there really are. And I'm just simply going to look at 14, 15, and 16 and see how many rows exist for each of those three values. And sure enough, there's not 11,000, there's 119. And that's more realistic. As the order quantity increases, the number of orders with that quantity, you would expect to decrease, and that's exactly what we're seeing. Other than that jumped up a little bit at 16, but that's not unreasonable. So what's the solution? Well, because this is simply statistics that was bad. In fact, let me do this. Let's do it two ways. I'm going to first of all execute it with full scan, and then we're going to look at the statistics. And notice that our blip is gone. Okay, now it shows us 119. But just to show you that this is not something I created, I'm going to update the statistics again, only without the full scan. So I'm going to let SQL Server determine the sample size, how and where to sample from that table to come up with the histogram. And then we're going to look at the histogram. Same query. And notice that the blip came right back. This is simply that the algorithm to create sample sizes is not perfect. We got a different blip, but it's still a bad blip. Okay, so let's update it with full scan and make sure that that fixes the problem. Now we're going to execute the same query. And let's take a look at the actual execution plan. And notice here is the sales order detail, and that looks awful good. And in fact, we're back to a nested loop, which again is the right choice with this number of rows. So have we fixed the problem? Well, only temporarily, because as you noted, if I update the statistics without specifying full scan, we get that blip back again. And that also means that if we get enough rows that have been changed in that table and the automatic update of the statistics comes along, it's going to happen again. If you are on SQL Server 2016 or newer, there's a new option, which is an awesome option. Persist sample percent equals on. So when I did that update of the statistics, had I specified to persist sample percent with that option, then the next time the automatic update of the statistics took place, it would use the percentage that I used with this. Now, this doesn't have to be a full scan, a 10%, a 20%, whatever it is that works, that sample percent will be remembered and executed, used the next time that it's automatically updated. So that's great if you're on SQL Server 2016 or newer. If you're not, here is the recommended choice. You use this tool, this system stored procedure called SP Autostats. SP Autostats either displays or changes the automatic updating of a system created, of a statistic, system created or otherwise. So if I just execute it with the table name, it will return all of the statistics in that table and their current status. Notice that every one of them is turned on, meaning that every one of them will get automatically updated when the time comes. Also notice that we have nice information the last time they were updated. That's handy. There's my OR again. So what you can do is actually two steps. Number one, you add a couple of parameters to that. You say, I want to turn off the automatic updating statistics for that one statistic. And the second execution here is just to show you, this is just to show you the effect of that. When I execute that, we will now see that this one statistic is turned off. It will not automatically update, because if it does, we're going to get those bad statistics again. And then you create a job or some other method to do the updating the statistics periodically or based on your own row count, whatever you want to do. But you have to do the updating yourself because now you've turned off the auto update. So this is what you need to do if you're pre-2016, but that persist sample percent works if you're 2016 or newer. Any questions so far, Michael? And I'm only asking that because I wanted another drink of my wine.
Well, someone was very complimentary of your use of Zoom It. They like the rectangles.
You're welcome.
We've had a number of discussions about using auto update statistics, but I think that so let's just do this. I think it may be something that maybe you have a conversation with this one fellow afterwards, but he essentially the summation of his problem is that when he sets auto update statistics to on, and when the statistics are being updated, there are timeout errors for queries. And so he's wondering how to prevent query timeout errors during the statistics update.
If you're encountering that, then you probably want to turn off the automatic update for that one statistic, because it's usually, again, case by case. Turn it off and then manage it in the evening when it's not going to affect other things. Yes, I've seen that. And again, that's a case to case. I wouldn't want to do that carte blanche, but yep, absolutely.
Okay, well, that was pretty much it. That was the main. We've been having back and forth discussions about that. So thank you.
That's a good point. Yep. And depending on how big the table is and how much the table is being used, updating the statistics can take a while and can impact other users. Absolutely. And there's the persist sample percent. Calculations. So this is an interesting one because it's kind of a roundabout to get statistics. So let me just go straight to my demo. And this is in the AdventureWorks DW 2016 database. And let's say that I have a predicate where I want to return rows where the order quantity times the unit price, in other words, the total value of the order, is more than $35,000. So that's a calculation. And the optimizer says, well, I've got statistics on order quantity and I got them on unit price, but gee, I don't know what it would look like if I multiply those together. So it has some algorithm that every once in a while works well, but often doesn't. And when you execute this and take a look at the statistics, and notice that from the fact table, 37 actual out of 18,000 estimated. That's quite a bit different. Notice that we got a hash match. Hash matches usually occur when you have a very large number of rows. And of course, it expects 18,000 here. And that's, well, okay, it's not a very large number there, but it's a hash match nonetheless. So what we can do, we can add a computed column to the table. So how much overhead is there with a computed column? If I don't persist it, then the storage of that computed column is nothing more than some metadata that goes with the table. And it's a tiny amount. It is the same whether you have one row or a billion rows in the table, it's metadata if I don't persist it. However, even if I don't persist it, I still get statistics on that computed column. So yes, I have a column on the table, but it's tiny, and all I get is that one 8K page of statistics, which is again pretty darn small. And the statistics can then help the optimizer come up with a better plan. So if I add that column, and of course, even if I had a billion rows in this table, adding that non-persisted column would be almost instantaneous because it's just metadata. And I'm going to execute the same query again with the calculation. And now when I look at the actual execution plan, notice that it's estimating 37 out of an actual of 37. So, and we went to a nested loop, which again, for a small number like that, is an appropriate plan operator. So that's a cheap way to solve when you have calculations, and it doesn't have to be 2 columns. It could be 3, 4, or 5 columns. You could have a computed column that has all kinds of calculations in it. If that calculation is used within a query, then the statistics could be used for it. The last example that I have is ascending key, which is a bit of a misnomer because it's not necessarily ascending and it's not necessarily a key. So think about the histogram. The histogram is up to 200 steps of sample values of a given column. And it has endpoints. It has the smallest value and it has the largest value and up to 198 in between. So when you add rows to that table, if though the value in that column is greater than the highest value in the histogram, then, and you submit a query then that says, okay, how many rows do I expect greater than the greatest value? The histogram says 0, and again, it can only estimate 1, a minimum of 1. So you could get a lot of rows outside of the range of the 200 steps that there's no information about, and the histogram doesn't cover, and the optimizer can come up with a bad plan. Prior to the rewrite of the cardinality estimator in SQL Server 2014, the estimate would be 1. If you said, give me everything greater than whatever, and that whatever was outside the range of the histogram, then it would estimate 1 and come up with a plan according to that. They improved that with SQL Server 2014 with the new cardinality estimator, and the estimator then is 30% of the number of rows that have changed in the table since the last time that statistics was updated. It is still an estimate. It can be too high, it can be too low, but overall average, that 30% is a lot closer than 0. Oops. So in this example, I'm going to add a bunch of sales order detail stuff. But I'm going to start by looking at the statistics on the modified date. And I put them in reverse order just because I'm interested in the largest value. The largest value in the statistics for the modified date is June 30th in 2014. There's no values, according to the histogram, greater than that. Well, I'm going to insert a bunch of rows. I have to insert the headers first. I think 2,000 headers. And then 4,000 detail. And by the way, if you're not familiar, then a number after the word go simply says execute this batch that number of times. Another interesting note that some people don't know, the word go is not SQL. The word go is in Management Studio, and that's a batch terminator. That word go never is sent to SQL Server. And in fact, in Management Studio, you can change that to be a different word. So, you could change it to the word select or something like that and have a lot of fun. But the point is, it does not go to SQL Server. So I now have an additional 4,000 rows in the sales detail. A little review of updating of statistics. There are thresholds of the number of rows needed. Once that threshold of the number of rows have changed in a table, then a given statistic is flagged as stale. And it says, okay, the next time a query comes along that references this column, before I execute the query, update the statistics, and then execute the query, then come up with a plan for the query. So that's what I'm going to do here, just to show that I have not inserted enough rows into the sales order detail table to trigger an automatic update of the statistics on the modified date. And I'm just going to execute this query. And if I had hit that threshold, executing this query would cause an update of the statistics on that column. So I'm going to execute it, and then just to show that in fact they have not been updated, we'll look at the histogram again, and sure enough, it is still the same. So I'm not trying to cheat and force stale statistics. These are stale statistics that could happen in normal events. So just to show you that in fact we have a whole bunch of rows greater than the greatest value in the statistic, I'm gonna look for how many rows are in there greater than that. And we have 4,000, exactly the number of rows that I inserted. So think about it now. There's 4,000 rows in the table with values in the modified date higher than the highest value in the statistic histogram. So the optimizer, depending on your version and your compatibility level, is going to estimate in two different ways. If we're in the prior to 2014 compatibility, which I'm going to put it in right now, it's going to estimate 1. I'm also going to turn on actual the statistics IO. I find that handy because that tells you the actual number of IO of pages, 8K pages, that had to be read to satisfy the query. IO is usually the biggest factor in how long a query takes to execute. So if I can reduce the IO, I can almost always reduce the time that it takes to execute. So execute that. I think I already did, but you can do it again. Okay, so now I'm going to execute this query where the modified date is greater than some value that I know is higher than the highest value in the histogram. And I'm going to look at a couple of things. I'm going to look at the messages to take a look. Oh, I didn't turn the actual execution plan back on. Let me execute it again. In the messages, we see the IO, and the logical IO is the important one. So we have a total of 13,700 something. So just remember that number. So this is what it is in SQL Server 2012 compatibility mode. Oh yes, and the execution plan. Notice that we have a nested loop, first thing to notice. Also notice estimated number of rows is 1, exactly what I said. It's all of those rows are greater than the histogram, but in fact there's 4,000. And because there was an estimated 1 row, that's why a nested loop was chosen. And had there been 1 row, nested loop would be appropriate. Let's see, without fixing the problem, let's see what happens with more recent compatibility level. I'll go all the way to current. Anything more than 2014 will give you the same thing. We're going to execute the same query again. Now when we look at the IO, we see 2,400. What was the other one? 12,000, 13,000. So we're talking tenfold, eightfold, some significant reduction in IO. And if we look at the actual execution plan, and I get this stupid thing covering it up. Now we have, here's the detail table, and we have an estimate of 1,200. Remember I said 30%, well, 30% of the 4,000 is 1,200. That's still a long ways off. That's still not a good estimate, but it's a lot better than 1. And it's good enough to give us a merge join, which is in this case a much better choice than a nested loop, because we don't have just 1 row. We have 4,000, but it thinks 1,200. So what's the solution to it? Well, we're back to how often you update statistics. If you have, I don't even have to do a full scan there, but if you have a lot of ascending keys, things such as date fields, I have a lot of tables with last modified timestamp that are automatically maintained with a trigger or a default, and those by definition are ever increasing. Identity columns are ever increasing. When you have those, the built-in features for updating the statistics is typically not going to be good enough. Of course, if they're never queried, who cares? But if they are queried, you may want to step in and take over. And let me do this without the full scan, just to show you that it doesn't have to be a full scan. But now that I do that and I execute, I take a look at the histogram again, now we'll see these newer values in here, okay? And now, when we look at the estimated versus actual after updating our statistics, then we're much, much closer. Before, with the 2015 or 2014 cardinality estimator, we were good enough in this particular query to give us the appropriate plan, the merge join. But this makes me feel a lot better that we're that close once we update the statistics. So when you have these situations, and I'll bet you probably have many of them, you have to manually manage them. One of the things that I've done many times is in tables that are populated via a stored procedure, like in an ETL process, if the stored procedure is all or the majority of the population of that table, then within the stored procedure, right when I'm all done updating it, I might check to see how many rows have changed, or maybe not, but I'll do an update of the statistics right there in the stored procedure. So I know that right after I update the data, I'm going to refresh the statistics. That is the end of it. So review, we looked at the optimizer and statistics, and we had several specific statistics solutions, and filtered statistics, and also composite statistics. Multi-column statistics sometimes can really solve a lot of problems. Computed columns. Are there any questions, Michael?
Well, one question we were having, we've basically going back to, I know you talked a little bit about very large tables, and I'm curious too. So do you have some recommended techniques? I mean, so when you have very large tables and you're partitioning them, so then you can do partitions, you can do statistics on the partitions, correct?
You can do partitions using the same parameters or same rules as the partitions. You're not really directly linking them to the partitions. You're just giving them the same logic, yes.
Now, what about the indexes on the partitions? Again, the same.
Yeah, in order to have statistics follow the partition, then the index needs to also be filtered following the same rules as the partitions.
Okay. Any other advice on very large tables in general, or with statistics?
This is where you really need to know how the tables are queried. It isn't, you can't say I need to have this index or these statistics on this table without knowing what the queries look like coming in. And you tune your queries, your indexing and your statistics to very much be aware of what queries come in. So I mean that's the key. You know, one thing I wanted to say and I didn't is that the optimizer not never but rarely makes mistakes given good information. So as a T-SQL tuner, you should consider as your primary role to make sure that the optimizer gets the best information possible. And that's why these statistics are such a cheap way, inexpensive way of giving the optimizer really good information.
Perfect. So we do have one interesting question. It says, I think this is from your demo. It says, with the computed column C equals A times B, you then use where A times B is greater than something and not C is greater than something. Does it matter if you use C or its definition A times B in the where?
Not sure I understood that. Repeat it, please.
I'm trying to sort out too. This is, okay, so this is what the Sebastian typed in. He said, with the computed column, C is equal to A times B, you then used where A times B is greater than something and not C is greater than something. I wonder if that was in part of your demo.
Oh, I don't know. I don't have a good answer for that. I will guess that it's an it depends answer. Yeah, I'm not sure.
Okay, yeah, he clarified. He said it was the total was C is equal to price A times quantity B. This may be something that might be better to take offline. I mean, I don't know if it's all right for him to email you or.
Yes. Oh, absolutely. In fact, I should have put on here my email address.
Sebastian, why don't you go ahead and email Vern? I think that might be, this is a bit of a clumsy way to ask the question. Not saying you're clumsy, I'm just saying this is not the best medium to do it.
There.
Okay, so there's Vern's email address. We do have one more question. This is maybe another one we want to take off the line. I have a question regarding the if function in views. It works in queries but not in views. Is this a bug in SSMS?
Oh, the nulls not being included in the histogram in the dynamic management view. Is that what it's referring to?
Well, maybe. Patrick, maybe email Vern on that one too. I'm just trying to think about that one myself.
So if you're referring to the dynamic management view, no, that's a bug in the definition of that dynamic management view. It's not Management Studio at all.
Okay.
Now it's documented. I posted the site that you can go to where it's listed as someone has submitted that as a bug, and you can vote on it and telling Microsoft, yeah, I want this. This is important to me. Can you fix it?
Okay. I don't know if that was it, but anyway, lots of good feedback. Everyone thought this was very valuable.
Good.
So I think that's it then. Everyone, thank you very much for showing up to this online session. Please don't hesitate to send feedback to either Vern or to leadership@OregonSQL.org, because we'd like to know how we can do better, of course. And I know that for sure we'll be doing the May session online. We'll have to see about June. We're just not quite sure. So I think that's it. Did anyone else on the leadership team want to say anything?
I've said enough.
I don't have anything to add. Just to remind everyone that we will be randomly selecting one attendee tonight, and we'll be contacting that person with our raffle prize. I'm not going to turn my webcam on because I, like Vern, didn't have the lights on in my office at the beginning of this meeting.
And I didn't notice it until just now.
It's like the frog in the kettle of slowly heated water as the lights go away. Just again, thank you for everyone for attending, and we'll look forward to seeing you next month. Arnie, anything to add in closing?
No, I think it all went well. Thank you, folks.
Thank you, everyone.
All right, stay safe. Take care, everyone.
Yeah. Thank you.